Hello everybody, today we'll be doing count distinct elements in every window of size k. So we are given an array of size n. Let's say this is an array. This is not correct, that we don't use curly brackets. And an integer of k, which is 4. Return the count of distinct numbers in all windows of size k. So basically, we're going to create a window between of size 4, with 0, 1, 2, 3, 4. That's our size. And with this window, we have 1, 2, 1, 3 as seen here. And as we slide the window over, we have another 4 distinct numbers and so on and so forth until the end. So for all the window sizes, basically n minus k, because we can't use the last 4 items, we will just have n minus k, right? So we have that many windows. So we have 4 windows, and therefore we will have 4 answers, and we have 3, 4, 4, 3, with the counting the distinct numbers. In this case here, we have a size window of 2, and we count 2 numbers, and then 1 number, because there's only 1 distinct number between 4 and 4. Some of the edge cases is to have a k at a very large number. If k is greater than length of array, what happens here is that we should just count everything. And if k is less than or equal to 0, then that means that we have no valid window. That means we turn like none. I think that's should be suitable for our edge cases. What about empty array, right? Empty array, something in k. I think what will happen if should we handle that? Yeah, I think we should handle that. Handle empty array. Right? I think handling empty array and also handling this particular problem here is the same, because it's basically the same problem where k is over the length of the array. Okay, so we have some understanding here. The match is going to definitely be match. What we're going to do is definitely going to be a sliding window. And there are 2 ways to do the sliding window. One way is to count these items using a set every single time. That's the easy way. But that's going to take us a time of n squared, because we have to count each set of numbers n minus k times. So n minus k squared. Never mind, my bad. N minus k squared, that's the timing. However, if we store this in a hash map instead, we can sacrifice time for space. And so instead, we could have a space of n minus k and a time of n minus k. I believe that we would want to sacrifice time for space. So I'm going to take n minus k using a hash. Rather than the space at n minus o of 1, right? So that's what we're going to do. We're going to do the second one, sliding window plus the hash map. All right, so that's our match. I think we reached the end of our space, and so we're going to do the planning up here and the implementation as well. Sorry about that. I'm gonna burp a little bit. All right. Had some soup earlier. All right. Bad posture probably. All right. Let's back on track. Definition. We're going to find our distinct elements in window. So, and we're going to call it R, and we're going to do a int array with k and an int, and we're going to return an R, an int R. So let's call this nums. I think that's a better way of calling this. Easier for me to remember how to deal with it. They're just numbers, and that's how it works. So, shoot, I burped and I forgot. I'm implementing already. So Let's talk about the plan. The plan is to create a hash map, and this hash map will hold the items in sliding window. Next thing we're going to do is create the sliding window and slide the sliding window and update the hash map. Add number of distinct numbers, distinct elements to results. Create results. Okay, these are some of the ideas that we have how to do this. It's not very exact or to the key. And what we're going to do is basically create the hash map that holds the items in the sliding window, create the sliding window. Well, we'll have to create the sliding window before we can create the hash map, okay? So we'll do that, and then we can create the results to hold the results. Afterwards, we're going to iterate through this item, this sliding window, to increment and decrement the I and j, so that we can check for the next distinct values. All right, so let's implement. So first of all, we're going to create our sliding window. So what's in our sliding window? Well, let's make sure we keep this in mind, because this is super important to make sure we have this in mind. First of all, because we're working with a sliding window, we're working with array, we have to see it. We're not robots, so we have to find out where our I starts and where our j ends. Suppose k is 4. So for I in range of k, we will be able to get 0, 1, 2, 1, and 3. Because we're going all the way till 4, right? So this is k. So we're going to go 0 through k, but not including k. We're going to take that and create our hash map, a sliding window, all in one. So hash map equals a dictionary. Okay, we also, we're going to push these items into our hash map now. So a hash map at the nums at I. So basically, this is going to be our number. And we're going to add this to our hash map. If it doesn't exist in our hash map, if it's in the hash map, we can increment it. If it's not, then we'll have to add. Earlier, I tried this problem with a distinct the dictionary, but default dictionary, but didn't quite work out for some reason. So we'll do it this way. So hash map at num is equal to 1. So with that, we have established our hash map. We have established a hash map where we have a couple values. So in the set item, we have 1, and we see it twice. 2, we see it once, and 3, we see it once. Okay, so what's next? Well, establishing our hash map and our sliding window, we need to create our results. So results equals an empty array, and first result we already know, dot append, is the length of this current hash map. We don't have to do it this way. We could do it some other way, but we're going to keep moving the items forward. So should we do a for loop, or should we do a for loop? I think we should do a for loop. For I, for j, or left right for right. Okay, anyways, I think this is easier. For right equals right is equal to currently we are here. We have this item that we will need to move on. This is our right. This is our left. So how are we going to do this? If we set this to, this is going to be k minus 1 then. Because this is k, 4. This is going to be 3, right? Our index. So while r is less than the length of the array, or nums, we're going to keep moving the r forward until it reaches that point. So what we're going to do is shift this forward and then update this this brand new set. Or we could update and then move. However, if we do plan to update then move, so let's say we update, then move, we update, then move, we update, then move, right? We're gonna run out of bounds. No, actually it looks like it will work. So we'll just have to be very cautious about how we do this, and we can move forward slowly, inch it slowly. So let's just append at the beginning. Let's say we begin at the beginning. Okay, everything's at 0, r is at 3. Okay, we appended. What's next? Okay, so what's next is that we move everything forward. So I plus equals 1, and r plus equals 1, and r plus equals 1. Okay, well, the question is, did we lose the I first? Well, we haven't lost the I yet, so we have to lose the I. Then we lose the L. We have to lose the L. So left num is here. If left num is in the hash map minus equals 1. I mean, it should always be in the hash map actually, so we shouldn't care. So okay, minus equals 1. So if it hits 0, then we need to remove it from our hash map. Okay, so that's good. Okay, so that means we are complete with this part, right? Then we move it forward. All right. Then we move the R forward as well. And we're going to add the item. So right num is equal to nums at R. And we're basically running this function again. If right num if the right number is inside the hash map, then we're gonna increment it. If it's not, then we're gonna set it to equal to 1. Okay, so with this move, what happened here is that the 1 became 1 less, and the R became 1 more. So we have 4 is equal to 1. So with that, we update that at the beginning of our hash map. And so now our results would show, first we had 3, now we have 4. Now we do the next step and we lose 2, and then we increment. And the same for the 2. So we update as well. So now we have 1, 3, 4, 2, which is the same, and we have another 4. So again, once we updated, we moved to the left by losing the item, by losing the 1. So we lost the 1. Now 1 is 0, and that disappears from our link from our hash map. So now we move this forward, and we add 3 back to our items. Now actually, we add 3 to our items, which is 2, right? And then we add it one more time, right? So what happens here is now we go out of bounds. So as you can see, we have just left our items, and we are now out of bounds. So we need another break here if r is less than, is equal to length of nums, then return, then break. It's not great code, but it works. But I can think we can make this code better a little bit later. So with that, we are done, and we can return our array results. So let's try it and see what happens. Ooh, that's not good. Sorry, I left you guys in the dust because I didn't see the window size. Sorry about that, but we can see it now. So let's try adding these numbers in and running the function to make sure it works, and then we can make some tests and run them as well. So let's just run, and hopefully there are no errors. Okay, there are no errors. Let's print, and then we can start running tests. Okay, so everything's looking good. It's not the best code in the world, because the best way to handle this probably is to append at the end, and that way when we're done, append the results at the end. That means when we're done appending, that means we exit, and that makes the code much more simple. But of course, by doing that, by appending at the end, we'll basically have to make one addition here. So we'll do that instead, and then we can move this down to the bottom, and we can move this to the bottom as well, so that after our movements that we make a change. So we remove the first one, we add the second one, and then we update. So that way we not good. So that way we can see that. Let's see what's going on here. Right, there we go. Because we started at K instead. So how does that work? So we added this already, and we started at K, right? So 1, 2, 3. That doesn't seem right. No, that's definitely not right. Let's just keep it back to what we had, and I think that will work. Because, yeah, it worked before, and it will work again. Okay, so we do have some issues that we want to handle. And those issues are going to be the test. We should test if it is 0, what happens. If the window size is 0, then we should just not return anything, because if it's 0, we have an error, right? So if k is less than or equal to 0, return none. Also, another case is that if k is greater, right? If k is greater, we're going to go out of bounds as well. So let me show you. So if k is like 10, and we're going to have another issue, see? So we're going to go out of bounds. So if k is greater than length of nums, k is equal to length of nums. So I think that will take care of it. Yeah, perfect. So with that, we have solved both problems, limitations, and that way we've taken care of the larger and smaller k's. So with that, I think we have solved the problem. If we want to solve this problem with more rigor, we can create test case, and that way we can build on top of that. Let me give me a moment. I'll get some boilerplate code, and we'll... All right, and we're back with some boilerplate code, as you can see here. Let's run it. It should return true. Okay, so next thing's next. Let's make more tests, and let's test our code a little bit more. So the test is going to run 0. That should return none. And lastly, if we put a window size 20 or 20, like, then we should have max. We should take all numbers and give us a max 4. Perfect. With that, we have completed the problem. We've done a review, and if you have any questions, well, we're gonna one more thing. We have to do our evaluation, and our evaluation of this is going to be O of n, because we just go through the whole n minus k times, and we also like have a like n minus k space because we store results. So it looks like we'll be using n minus k either way because of the results. So I think we did save some space here. So time, because sliding window. Okay, with that, I leave you to solve this problem on your own, and I hope you enjoyed this video. Like and subscribe, and I will see you in the next video. Thank you. Bye.